One of the many places that you will see polynomial and rational inequalities is in application problems throughout physics and mathematics. So we're going to start with a physics problem. If you have an object that is falling or projected into the air as a projectile, there is a formula that you can use in physics, and that is S of t, which is shown here on this slide. In this problem, t is measured in time that the object is in motion in seconds. V sub 0 is the initial velocity of that projectile, and S sub 0 is the initial position or the initial height of that projectile in feet. And if you can just plug in that V sub 0 and S sub 0 into this equation and work through for any problem. So we're going to do that. So we have a projectile that is being propelled straight up from ground level with an initial velocity of 80 p per second. So I filled in the V sub 0 as 80 and the S sub 0 as 0 because it is on the ground. So its height at time t is modeled by this S of t function, which is negative 16 t squared plus 80t. Again, the height is measured in feet and the time is measured in seconds. All right, and the question is, in what time interval will the object be more than 64 feet above the ground? So they're asking us, when is this equation, negative 16t squared plus 80t, when is that going to be greater than 64? So when is the height going to be greater than 64? So I am just going to move this around a little bit. So I'm going to move the 64 over. And then I'm going to factor out that negative 16. So when I factor that out, I'm left with t squared minus 5t plus 4. And that is greater than or equal to 0. And that trinomial in there I can factor. That's t minus 1 and t minus 4. So we have two times for our boundaries. Our boundaries are t equals 1 and our boundary is t equals 4. All right, so on my number line, here's t equals 1 and here's t equals 4. So I have two boundary points, three very distinct intervals. I notice that neither of these boundary points will be included because my inequality symbol is strictly greater than. So neither of these will be included, so I'm going to put round open circles right there so I know that they are not included. All right, another thing I know about my number line is that because I'm discussing time, time cannot be smaller than 0. So I don't even need the rest of that number line on the left. Time is going to start at 0, so I don't even have to go any farther on the left. So I'm going to test these three intervals. Now, there are some shortcuts to this, and although I didn't discuss them in the previous video, we will discuss them now because it's important. This is a parabola that is opening downward because the leading coefficient is negative. So if I were to sketch this graph, it would look something like this. It'd be a parabola that was opening downward, and those would be the two x-intercepts of my parabola. So I can use that information to help me, that will let me know that this portion of this interval here will be negative, this portion will be positive, and this portion will be negative without actually testing each point individually. So if you already know the shape of that graph, you can take the three-dimensional and kind of make it into that one-dimensional, the two-dimensional graph, and make it one-dimensional by looking at just what's positive and what's negative. But if you don't want to do that, you can just go through like we did in the previous video and test each interval individually. So in this case, I am looking for when this parabola is greater than or equal to 0. So I'm only looking for the positive section, which is this section in the middle. So for the interval from 1 second to 4 seconds, not including those, that will be when that projectile is more than 64 feet in the air. So from 1 second to 4 seconds. All right, let's do another example. This is a bit more involved. You're going to have to think on several levels here. So a perimeter of a rectangle is 50 feet. Describe the possible lengths of the side if the area of the rectangle is not to exceed 114 square feet. So a couple of things we have to walk through. The information they gave us was about the perimeter. And perimeter is always 2 lengths plus 2 widths. And I know the perimeter is 50 feet. So I can simplify that equation to 25 equals L plus W. All right, the second thing it's talking about is area. And I know that the area of any rectangle is length times width. Now, I don't want two variables, so I need to change either the L to it being in terms of W or the W in terms of L. So over here with my equation, I'm going to say that W is equal to 25 minus L, right? I'm just going to subtract L from both sides. So over here, instead of W, I can write 25 minus L, which will help me clean this up a little bit. All right, so my area function is equal to L squared negative L squared plus 25L. So there's my area function. And we need to find when that area function, it says it's not to exceed 114 square feet. So that means that I want the area not to exceed. So it has to be smaller than or equal to, it can be equal to 14, but it's just 114, but it can't exceed it. All right, so I'm going to clean this up a little bit. I'm going to move, let's see, let me move this over here. So negative L squared plus 25L minus 114 has to be less than or equal to 0. I'm going to factor out that negative. So that's going to leave me with L squared minus 25L plus 114 is less than or equal to 0. Okay, I like that a lot better. So again, also a parabola, also opening down because the leading coefficient's negative. So once I find my boundary points, I'm going to know immediately what part is positive and which part is negative. All right, so first I'm going to check to see is can I factor that trinomial, which I can. Lovely. Factors of 114 that add up to negative 25 are negative 6 and negative 19. So that means I'm going to have a boundary point at 6, and I'm going to have a boundary point at 19. So on your number line, again, you also have to think about, we're talking about the area of a rectangle and the dimensions of a rectangle. So I'm going to start at 0, because I can't have a dimension that's less than 0. So my number line is going to start at 0, and it's not going to go forever, because I know that the perimeter has to be 50, so I know it's going to be very, it's going to end. So we would probably end this at 25, because 25 times 25, 25 by 25 would not be, it would not even be a rectangle at that point, right? It would be two sides, but we wouldn't have any room for the other two sides. So I know that this is going to end at 25. So I could have a rectangle that's 24 by 1, and that would work. But I couldn't have it 25 by 0, because that wouldn't be a rectangle. So I know that my number line is going to be very shortened. But even if you didn't know that, you could still just use those boundary points of 6 and 19. And you know also this is going to be a parabola that's upside down, right? So everything's going to be positive in the middle, it's going to be negative over here, and it's going to be negative over here. So I know that my dimensions that will solve this, oh wait, I want them to be negative. Okay, here we go. Less than or equal to, so I'm looking for the negative portions. I thought I was looking for the positive portions there for a second. So less than or equal to means I'm looking for the negative, so my answer is from here to here and from here to here. So the lengths of the side can be between 0 and 6. Now, but can't include 0, right? Because I can't have 0 be the length. So 0 is not included. 6 is included, right? Because there is an equal sign. 19 is included because there is an equal sign, but 25 is not included because I can't have a rectangle that's 25 units in length, because that would mean the other length would have to be 2. Well, that could be. Yeah, it could work. Oh, the area is 114. Oh, I was thinking about the perimeter. So scratch that. 25 not included. Can't have a length of 25. All right. So my answers are: I could have 0 to 6. 6 is included, and I could have 19 to 25. So this one, a lot of extraneous information that you'd have to know about geometry, and you'd have to know about perimeter and area. So there's a lot of extraneous information that you may have to know, which is why these application problems can sometimes be really challenging, because you have to have a lot of outside knowledge about the topic. So this next example might be a little bit more pertinent to you and your studies. So how many questions can a test have if I can miss 5 questions and still score a 70% or less? Okay, so first of all, 70%. Make sure you always write percentages at decimals. So I'm going to write that as 0.7. All right, so we want our score to be a 70% or less. So the score has to be less than or equal to 0.7. So I'm kind of taking the words and slowly changing them into symbols and changing it into a mathematical statement. All right, how do I find our score on a test? Okay, so the score on a test that we get is always going to be the number that we got correct. So over here, I'm just going to make myself a little, the score is the number correct over the total number of problems on the test. Okay, and I don't know either of these things, right? So let's say that x is the total number correct. So my score is going to be over x, because that's going to be the total number I've got correct. And then the total number of problems on the test. The number I got correct, now this says I can miss 5. So if I take the total number and I subtract 5, that's going to be the total number that I got right. And again, I don't know how many questions are on this test, so I'm just going to say it's x minus 5. So if you look, do you see that you now have a inequality? Okay, and there's a couple ways. We could do this on the numbers, number line. We could just solve it as it is. We have some options as far as these applications go. You don't always have to solve them using a number line. I just think the last example we did with the geometry, you really needed the number line because there were so many things that you had to keep track of in this problem. So this inequality, I think I'm just going to solve it, and we'll go from there. So I'm going to multiply both sides by x, and I get x minus 5 is less than or equal to 0.7x. I'm going to subtract x. Actually, what should I do? So I subtract x from both sides. You know what? I'm going to get all the x's together. So I'm going to subtract 0.7 from both sides. So that gives me positive. Me and my symbols. All right, see me and my signs. 0.3x minus 5 is less than or equal to 0. I'm going to add 5 to both sides. And then I'm going to divide both sides by 0.3. And 5 divided by 0.3 is 16.66666. So 16.666 means I can't quite have 17 problems, right? So the maximum number of questions is going to be 16 questions on that test. What's the minimum number? Well, it says I can get a 70% or less, so I could get a 0 on this test technically. And if I got a 0 on the test, that means, and I missed 5 questions, that means I would have missed all of them. So the minimum number of questions is 5. Because if I miss all 5, I would get a 0 on the test. If I miss 16, I would have just under 70%. All right, so again, even with applications, you still have to have a lot of knowledge of what's going on in the world around that. So please make sure that when you do applications, if there's something you don't understand or you don't know, do a little research first, so that you're familiar with the topic that is in the application problem. All right, so hope this helps. You will have some application problems to practice, hopefully, and come back next time when we start talking about radical equations.